Hello and welcome to the course. Today we want to consider couplers from advanced course and we will see what we learn. So now you are looking at a coupler in KNX. So what are the reasons of providing the couplers like line coupler, backbone coupler, or IP router? First of all, you should know that this coupler is not a bus coupling unit. These couplers transfer data between electrically independent parts of the KNX installation. One of the big tasks, and I can say the important task of the couplers, is to reduce telegram traffic throughout the installation with the help of filter table. Filter tables are automatically calculated or provided by ETS when you do the link in group addresses. Of course, you can add it manually or delete it, remove it manually. Filter tables are transferred into each coupler via the program application. So it is so important. Every change in group addresses, the links, it affects the filter table in couplers and you should re-download it, okay? And make sure about the latest change of parameter or group addresses are downloaded into the line coupler or backbone coupler or IP router. If a ETS has determined a change for a filter table, it resets the GRP tick and thus signals that transfer to the couplers has become necessary. Note that when we talk about GRP flag, it means when we, for example, are going to download the line coupler in ETS, we should be assured that we have the green tick in GPR here inside of device, for example, window, okay? And if you make change in link through the group addresses that are related to the line or areas of that coupler, so this GRP tick from the green is changed to the gray one, okay? So then you should re-download it to make sure that you have the green tick here. So how many coupler type we have in KNX? Interesting. So first of all, we have the line coupler. It means this device that we have it here, the primary side and the secondary sides connected to the twisted pair, okay? The primary side is, for example, connected to the main line and the secondary side connected to the secondary line. So line couplers, we call LC, connect a TP line with the TP main line. Backbone couplers, BC, connect the TP line with the TP backbone line. So as a hardware, the backbone coupler and line coupler are the same, okay? So we use the same hardware, but when you choose the right physical address, you make difference between the line coupler and backbone coupler for these type of couplers in KNX. We have the PL power line media coupler links a power line with the TP main line. We have the RF media couplers link a RF line with the TP main line. So here you see the blue devices with KNX connector. This is from the company named Wenzel in Germany. So this couples the twisted pair line to the RF or radio frequency or wireless type of KNX line, okay? So if you want to connect the wireless devices of KNX or based on KNX to the KNX twisted pair, you should use the coupler between these two. Of course, in ETS 6 with the new devices that are coming soon, you can use the segment coupler and connect the devices to the same line. But currently, if you want to add the RF line, you should make the new line with the RF coupler or radio frequency couplers and link it. Then here you can see the IP router. KNX IP router link a TP line to a network area. We use the Ethernet cable, here you can see in the device, to connect the primary line of this IP router to the world of network with high speed, 10 megabyte, 100 megabyte, 1000 megabyte, and so on. Yeah. Okay. So with the IP router, you can replace it to the line coupler, or you can replace it to the backbone coupler. Okay. So we talk about the differences between the coupler and bus coupling unit. They are not the same at all. And also, we want to talk about the couplers and interfaces. A basic distinction must be made between these two types of concepts. Interfaces, in contrast to couplers, are devices that link a KNX installation with other technical equipments, means gateway. These type of interfaces, they are not fully integrated into KNX installation and do not have a filter table. So with interfaces, for example, between KNX, Modbus, KNX, Dolly, and so on, you do not have the filter table, and you cannot control the traffic of the data. Instead, such devices have a table that assign group telegrams to the elements of other system. Interfaces are frequently also designated as a gateway. So the book provides some example of gateway. For example, the gateway between KNX and PSTN telephone command, or between the KNX and Profibus in PLC, or between the KNX and a special radio frequency protocol, for example, from some company like Insta, or many other things. Okay, so when we talk about the couplers, we do not consider they as interfaces. These concepts are totally different. Couplers for TP can be used as a backbone coupler, BC, line coupler, LC, and line repeater. So notice that we have the same device. For example, when we are going to the catalog of some devices of some manufacturers, we saw only one hardware. So here, for example, in ABB, we have line coupler. So this device can be used as a line coupler. Also, it can be used as a backbone coupler, and also it can be used as a repeater, okay, as a line amplifier. So how we make the difference with the physical address? We make the difference between line coupler and backbone coupler, and for repeater with the different application program or some specific setting in parameter. Okay, so the important things is the hardware are the same. Great. So when we continue with the book in this chapter, we will see that there is a table that provides some key information about what we had in B4 for the couplers, and now what we have, I mean, at the moment. So before 2003, the couplers use the battery to hold the data, or we can say record the data, okay, and it works for 10 years. But nowadays, after 2003, the information is written on EEPROM, and when we do not have power supply, the information would remain on the device. Then, of course, in B4, it's so bigger, and now it's thinner. Yeah, Then what we have in the before is how we energize the line coupler or backbone coupler. Important at the moment when you want to energize it, it is only energized by primary line. Okay, so we should have the power supply on primary line like the main line or backbone line. But in before, the couplers are energized by the secondary line. Okay, then another important thing is in before, the secondary line was the connection to the secondary line was data rail, and of course the primary line was the KNX socket, KNX connector. Nowadays both sides has the KNX connector. As you see in previous slide, both sides has the KNX connector. Then important differences in before less than 2003, the main group addresses was 0215 because of ETS3 and before, but nowadays in ETS5 and ETS6 the main group address range is between 0 to 31. So in before, the group addresses which were located in a main group address 14 and 15, there were no filtering for those. Okay, and of course we should consider this fact nowadays when we want to do the parameter in line coupler related to the before, all the old ones. So there are some key differences between before and today in couplers. So now we want to focus on the parameter setting for most of the line coupler and backbone couplers in KNX. You can see we can decide about the transmitting of the data from the main line to the line, or to the line to the from the line to the main line. Also, in most of the case, we should make the decision for main group addresses 14 and 15. We can consider if the repetition of the error on a main line or line should be considered or not, and also if the telegram confirmation on a main line and line should be considered or not. Okay, good, we continue. When we want to make the decision about the transmitting of the data from the line to the main line or from the main line to the line, there are three options. Normal, it means with a filter. It means the filter are applied, and by default in parameter always for the couplers these settings are set. And also we have the route. It means there is no any filter and all the telegrams can be routed. And block, it means no telegram can transmit from the main line to the line or from the line to the main line. So this is so important. By default, we do not touch the parameter setting in couplers. We keep it in filter type because we want to control the traffic of the data and do not let the useless telegrams to route from the couplers. Yeah, so we keep it in filter type, but maybe in some situation you want to route it for some time and then bring it back to the filter, okay? Or because of some problems in future you want to block it at all and make the separation from your line or area to the other ones. So these possibilities are provided in parameter setting of the couplers. Another important things that are mentioned in a book is when you use the filter, for example, from the line to the main line, okay, and you put your visualization in the main line. So there is no transmitting of the data from your line to the main line because most of the time the visualization do not have the ETS setting and ETS parameter and ETS objects, okay? So in this situation, there are two solutions for that. First of all, some visualization provide you the dummy application. So you have the dummy objects. So you use the dummy objects link between the main line and your line, okay, to let the ETS provide you the filter table that routes the telegram from the line to the main line. This is one of the options. Another option is to add it your group addresses to the filter table manually in ETS. So later I will show you an example how you can add it or remove it manually. So this is important also. So when we talk about the dummy devices, it means, for example, in a KNX, we have the visualization here, okay? And by default, because there is no any group address link between here and these from to here, okay? So there is no telegram can transmit it from the line to the main line or to the backbone line, okay? But if there is the dummy devices with dummy objects from here and you make the link between this device and the line, okay, so the route can be possible from here and here. So this is possible. But there are the better way. The better way is you see which group addresses you want to use here, okay, in visualization, the group addresses, for example, we want to use here in the visualization, and then we add it manually to this filter table and this filter table, okay, and you let the routes to be happened. Yes, so this is what we do in the project, and of course in visualization also we mentioned to that. In previous couplers, we have the parameter set check filter table, but nowadays we do not have it, okay? But because the book mentioned, I provide you the paragraph. A test algorithm is activated via this parameter. It checks the filter table for data loss through the evaluation of checksum. The following options can be set. Yes, the filter table is checked cyclically for errors. No, the filter table is not checked. Nowadays, with the new type of couplers, the parameter check filter table is always set. So this nowadays the filter table is checked cyclically for errors because we need it, huh? So that's it. Okay, but in old filter table also we have the parameter called on error in filter table, okay? This is only for old type of couplers. If the coupler establishes a defect in the filter table, the setting of parameter on error in filter table determines the behavior route, block or ignore. If it is set to the route, bus load increases, installation continue to function, fault remains undetected. If block, malfunction of the installation, fault becomes apparent. If ignore, couplers behave according to the first two parameters, group telegram. Fault does not become apparent or only very late. So nowadays, for the new type of coupler, this parameter is always set internally to the route. About the parameter main group addresses 14 and 15. Entries for all group addresses of main group address 14 and 15 did not originally fit in the filter table memory. They cannot be filtered by address but only be routed or blocked collectively. So this is important. Always you should consider about the main group addresses 14 and 15 and see your couplers how to behave, okay? For example, about this parameter setting that book provide for us for main group address 14 and 15, we can tell the couplers by parameter setting to route or block. That's it. So there is no any filter for that, okay? If main group 14 and 15 are used, they should only be used for internal line connect functions. It means, for example, you use some central function in main group address 14 and 15, okay, and then put it here to the routes. So, for example, you want to set the set point of the thermostat for whole of the building. So you put it in main group address 14 and 15, okay? Because you want, with this type of coupler that book provide for us, they should be routed, okay? And there is no any filter or a control of the traffic of the data for main group address 14 and 15. But maybe in your project, your couplers will differ from this type, okay? So you should consider about your couplers, go to the manual, read it, and see how your couplers behave for main group address 14 and 15. Yes. Okay. The next parameter, the book provide us some points about this, is repetition if transmission error on mainline, or repetition if transmission error on a line. These parameters control the repetition process if there is no acknowledgement or only a negative acknowledgement on the corresponding lines. The following option can be set here: none, or 1, 2, 3, or yes for the new type of couplers, okay? Yes, no for the new type of couplers. So it means in a new type of couplers, you tell the couplers you can repeat the telegram if there is some error, okay, in a main line or a line, or you should not repeat it, huh? The last two parameters, telegram confirmation on a main line and telegram confirmation on line, determines the acknowledgement process for received telegram, okay? So only if routing the telegram is only acknowledged if it is routed by the coupler. Always it means all received telegrams are acknowledged. These parameters should only be modified in specific cases as the following example. So by default, okay, the repetition of error on a main line is activated, and repetition for errors on a line is activated. Also, sometimes we should change it, and now we will see when we should change it. For example, a visualization PC is connected to the main line via the data interface. Means, for example, IP interface. The filter table of the line couplers are activate, and the filtering is set in such a way that the telegrams for the visualization can reach the main line. If telegrams which only address the visualization are now routed to the main line, the acknowledgement is missing for the line coupler, and telegrams are repeated 3 times, which leads to high bus load on the main line. This can be remedied by changing the parameter telegrams confirmation on a main line to always for all lines couplers, so that all couplers respond and telegrams is not repeated, or change the parameter repetition of the telegrams errors on a main line to none for all couplers, so that the telegram is likewise not repeated. The disadvantage is that the telegrams are lost if transmission error actually occur, or if the input buffers of the couplers are full and send busy. This option is, however, the only one available if there is only one line coupler present. Notice that what the book said, if you concern about the traffic, the load of the bus, because when the telegram is not acknowledged and you set the parameter to repeat it and repeat it, so it can increase the rate of the transmission of the telegram, okay? So you can block it, and you can ignore it, the repetition. In this case, maybe you lost some telegrams, but you never face the problem with the high bus load. Yes. Another point is, another example that we change it is, a visualization piece is connected to a secondary line, okay, not in a main line, via the data interface. The filter table of the line coupler are activated, and the filtering is set in such a way that the telegrams for the visualization reach the line. If telegrams which only address the visualization are now routed to the line, the acknowledgement is missing for the line coupler, and the telegram are repeated 3 times, which leads to high bus load on the line. This can be remedied by changing the parameter repetition of the transmission error on a line set to the none for the coupler. The telegram is therefore not repeated. The disadvantage is that telegrams are lost if transmission error actually occurs. Please note that we never change this parameter by default in couplers. We keep it, okay? In some cases, maybe you need to change it, okay? If you want, if you know you have the some transmission error, okay, and you do not want to receive it again and again or repeat it again and again, you block it. That's it. But about the line repeater is only the amplifier in the old topology. From the topology 2020, we do not have line repeater anymore, okay? So with the new devices, if it is written in a datasheet, you can put 256 devices in one line. That's it. But for the devices in the past, older than 2019 or 2020, if you want to put more than 64 devices in a line, you should use the line repeater. Notice that the line repeater is with the same hardware of line coupler and backbone couplers. Okay, so this line coupler can be used as a repeater. But the physical address is changed and the application program or setting the parameter. But what parameter setting we use it? You can see in the picture. The repetition if errors on a main on a line in assigning physical address is no. Repetition if errors on the main in group telegrams, yes. Repetition if errors on a segment in assigning physical address, no. Repetition if errors on segment in group telegrams, yes. So note to what we have in here, but remember that in repeater you wrote all the telegrams. There is no any filter table in line repeater. Remember that. As the ETS program does not make a distinction between different line segments, it is not able to create a filter table for a line repeater. The repeater therefore wrote all group telegrams. Please note that there is no control of the traffic of the data in line repeater. Telegrams with physical distinction addresses are also generally routed. Okay, interesting. We want to provide you some example, and we will see how the example is done, because we want to provide some example in ETS, okay, and show you how the filter table is provided in ETS, because we can see it. The filter table is generated in a background of the ETS. Okay, in ETS 6, we want to provide 2 lines, for example, in one area. Okay, line number 1, and also we want to provide line number 2. Okay, TP line number 2. Okay, and this is TP line number 1. In TP line number 1, we want to add, for example, in ABB, for example, yes, the line coupler, line area coupler, we add it. Also, we have the coupler in line 2. We add it. Okay, so you can see we add the line couplers. Then in ETS 6, make sure when you want to add coupler, because the primary line is TP, you should come to the TP area, okay, and from the right side properties setting, you choose the main line medium from the IP to the TP, okay, because when you create the new project, it's automatically the main line is IP. Okay, so you put it in TP, and then you can see when you add the line coupler, the physical address is automatically 110 for the line 1 and 120 for the line 2 of the area 1. Okay, so then we continue. When we continue, we add the push button, okay, push button to the line 2 and to the line 1. In each line we have the push button. Also, we will add the switch actuator. Okay, so here we add the switch actuator to both lines, and we have the keypad in line 1. What we want to do is, From the push button number 1, okay, here in line 1, we want to control the relay actuator or output 1 of this switch actuator. And from the push button number 1, from another line, we want to control the relay actuator number 2 or output 2 of this actuator in line 1. It means we want to control something in the same line and control something in another line. And we will see that the ETS automatically block or route the telegrams. Okay, good. So now I'm going to set the parameter and make the group addresses. Okay, here for the keypad, we can see the number 1 and number 2 switching is available. We will go to the switch actuator. Okay. Then in the parameter of switch actuator, by default it is located in shutter actuator. For this type, no problem, we put it in switch actuator. Okay. So in this case we have switch actuator number A and number B. Okay, great. So also for line number 2 we should do the same parameterization. In here we change it from shutter to switch actuator, and that's it, it's done. Great. Now I'm going to create the group addresses. Go to the group addresses. Here in group addresses I said, okay, this is floor number 1, okay, and floor number 2, 2 main group addresses. Each one is with lighting, okay. The middle group addresses, and each lighting we have the control switch on off outputs A. Okay, great. And here also control switch on off out A. Great. But this out A is for the actuator in the same line, okay? This out A is for another line, line number 2. So here I make the connection between the first row of the keypad, okay, and output A of the switch actuator. Here I use the switch actuator, the second switch actuator in the next line, the group objects, but to control it I want to control it from another line, so I use the push button number 3 and 4 for that. That's it. So ETS provide us automatically the filter table. It means the ETS said if you want to do some control inside of the line number 1, there is no need to transmit the data. Okay, so the 001 is blocked and we will not see it in the filter table. But if we want to control another line, okay, so the routes from the line coupler should be done, should be provided. So we will see in filter table 100. So how we can see the filter table? You should go to the line coupler, right click and click the preview filter table. Yes, you can see the 100 is provided, but the filter, the group address 001 is not shown here because it's blocked. Okay, also because the route should be done through the 2 line. Here also in a filter table you should see it. Great, great, yes. Okay, if here, for example, I provide another group addresses, group address test 01. Okay. Test 01. And if I go to the here in the and push the preview filter table, you can see there is no the test group addresses. It means 101. Okay, but and here there is nothing. But there is two ways to add it. You can click on it and drag and drop it, for example here. So this is added to the filter table. You can see the 101 is added here. Great. If you want to delete it manually, you should come to the line from the right hand side, properties, information. The manual filter table is shown here. You click on what you added manually and click remove. That's it. And if I come here and see the preview filter table, you cannot see 101 anymore. It is deleted. So manually you can add or remove it. Of course, from here, if I push the line from the right hand side, you can write here, for example, you say, I want to add 101. You add it here, and from left hand side, you can go and press the filter table. You see, oh, it's coming here. Great. So in visualization, the group addresses you want to let the route happen, you should add it manually to the line or main line or backbone line or whatsoever you need it. It really depends on your project. Okay, so this is a great example. Now let's continue. You can see the topology of KNX here, and you can see what we have in the line coupler, backbone coupler, line repeater. You can see the routing counter from the first time is generated by number 6, okay? When the routing counter pass each line repeater, line coupler, backbone coupler, it reduced by 1. And when the routing counter is reached in the in the very, very far way, reaches to the 0, then the telegram with the routing counter 0 never ever pass any line coupler or backbone coupler. So if you connected the two line in a different, in a wrong way, okay? For example, you make the loop not deliberately, but not on purpose, by mistake. So because the routing counter after one loop is going to be 0, so the telegrams is banned and blocked. So this feature of KNX can help us to not have a very worst case. Yes, great. Line repeater do not filter. They should therefore not to be used in the planning of new KNX installation, but only in the extension of existing one. So in a new KNX installation, you never use the line repeater, but maybe you want to extend something in before, you use the line repeater. Great. Also, I told you through the example how you add the manually or remove the manually group addresses from the filter table. Okay, IP router. IP router is not only like the line coupler or backbone coupler, but also provide us a high speed in the upper layer, in primary side, okay? This IP router is a simple interface connection to higher order system throughout the use of Ethernet Internet Protocol, IP. It is direct access to the KNX installation from any point in IP network, rapid communication between KNX line, KNX area and systems, communication across building and properties, networking of properties, filtering and routing of telegrams according to the. It's really important. It's provide us the filter table. It's exactly like the line coupler and backbone coupler. So it accepts exactly the same physical address. Remember that. It provides us the filter for individual address and group addresses. Okay. Also, there is some indicator on it to let us know the operation. For example, the readiness of operation, KNX communication, IP communication. Simple configuration with ETS without plugin. There is no need of plugin. You only download the application, provide the application from the catalog view and download it to the device. Simple interface connection of visualization system. In most of the time for visualization system, you can use the IP router because it provides us the point-to-point communication based on TCP IP, and so we can use it. Yeah. Individual address of IP router. IP router can adopt the function of both backbone coupler and line coupler. An IP router can in principle be used as a line coupler or as a backbone coupler. Okay, so really is the same in physical address. The individual address or physical address for IP router have the same formats of what we have in TP-TP couplers. Careful planning and assignment of the individual address is more significant for IP routers than for classic line backbone couplers, as a main line or as a backbone line can lie on the same medium Ethernet. What is physically in pure TP installation as a bus cable is somewhat abstract in the IP installation and only determined by individual address. So this individual address is really important. You should take care of it. So first of all, we can replace the backbone coupler with the IP router. Okay, so for example, in the big topology, instead of 15 backbone coupler, we have the 15 IP router. The IP router for area 1, the physical address is 100. Okay, the IP router for area number 2 is physical address is 200. And the secondary line of the IP router, that is twisted pair, is connected to the main line of the area that is fully based on twisted pair. The recommended setting by the KNX is to replace all line couplers with IP router. In this case, we do not have a backbone coupler anymore. They are vanished, okay? But we have the different areas and different lines. And how we make the difference? By assigning the right physical address. So the IP router in line 1 area 1, the physical address is 110, and the IP router in line 2 area 2 is 220. Okay, great. Of course, the book said you can use the combination. It means in some area you replace the IP router with the backbone coupler, okay, like here, area number 2, and the whole of the area is based on twisted pair. But in some area you can replace the line coupler with IP router. It is possible, but this topology is highly recommended in KNX. The next important thing is network setting of the IP router. So let's go to the real IP router. We try to see what is the setting of for the IP router in ETS. So here, in for example, the Xenia IP router, we can see when we go to the parameter setting, we have the IP configuration. In IP configuration, it is mentioned, do you want to use DHCP? It means this device in a local network receive the IP automatically or not. Okay, so by default, always this is in DHCP mode. So you should have the DHCP server, like the simple DHCP server. We have it in the ADSL modem or whatsoever in our local topology. Okay. Also, you can make it in a static way. So here, if you put the DHCP in do not use, you should provide the IP address, for example 192 according to your need, 168, for example 110. Okay. This is the net mask, and this is the gateway 192.168.1.1. Okay, and the DNS can be empty or the Google DNS. Okay, so in this case, this IP of this router always set like this. Okay, so you can make it in a static way. Okay, the KNX multicast also. Of course, this is it is used. It is used the default one from the KNX, but maybe you want to use it for according to your network rules in your building. So you can define it by yourself according to what IT man of the project said. Also, in another router, maybe the place of IP is different. You should go to the parameter from right hand side in properties. You can use from the obtain of IP address to use a static IP address, and you provide the IP address here. So there are different ways to set it, and so on. So be careful about the setting of the IP address, because we want to communicate with the router in a right way. Okay, great. Thank you so much for listening to me, and I hope you learn something useful. Please let me know if you have any questions by email or WhatsApp or similar connection. Thank you so much. Have a nice day. Thank you. Bye-bye.